Hi there. Today we are doing financial mathematics for grade 12s. In this lesson number 1, we will be learning about how to choose the correct equation or formula for any financial mathematics problem. This lesson is proudly brought to you by Infinite Wisdom Tutoring. Let us start by perusing through the equations which we use in calculations. First, we need to notice that there are two categories of calculations or two categories of formulas. The first one is the ones of payments and the second one is the continual payments. In the ones of payments, there are 4 equations. 2 of them are interest equations, equations where we are dealing with increasing in value. And the 2 equations are equations where we are dealing with decay or depreciation, where something is depreciating in value. On the first 2 equations, where we are dealing with interest, it is first the simple interest and the compound interest. The simple interest is simply an interest which you will notice that in the question there is no mentioning of any compound or compounding. The question will be like, Sarah saved an amount of 30,000 and was offered 3% per annum. So immediately after the mentioning of the percentage, there is no compounded. Whereas when it comes to compound interest, they will say Sarah saved 30,000 and was offered 5% per annum compounded monthly or yearly or whatever compounding that they have chosen. So you will notice that with the simple interest, there is no mentioning of a compounding, and with the compound interest, there is a mention of a compounding. And when it comes to inflation, inflation is part of the compound interest. To notice a once-off payment, you need to notice that in the question, the person paid only once to the bank and did not continue with recurring payments. Whereas in the continual payment, you will notice that the person continued paying to the bank, wishing to get a larger amount at the end, or perhaps got an amount now and is repaying the amount with smaller amounts. So as long as there's a continual payment or a recurring payment, which in financial mathematics language we call it an annuity, then that is falling in the category of continual payments. Let us look at the depreciations or the decays. With the decay, to see the first one, you will notice it by being said. It will be clear that this is a simple decay or a straight line depreciation question. How so? The question will be like, Ntlanhla bought a car, and after purchasing the car, depreciation on the car is calculated at 5% using the straight line method. Now you know that you are going to select this equation to calculate the value of the car in the future. And if they mention that it is using reduced balance method, then you will use this equation. The A here is the future amount. The P is the present amount. And the I is the interest rate, whereas the N is the number of years. We have to notice that. And for all of them, these variables are the same. A is the future amount, P is the present amount, I is the interest rate, and N is the number of years. Just to notice that here it's supposed to be a negative and not a positive because interest is decreasing, and the N is a superscript, or we can say it is an exponent. When coming to the future value or the future annuity, where we are dealing with the continual payments, this F is the future amount, whereas this X is the amount that you pay continually with constant values. For example, if you are paying 500 every month towards an investment, then that 500, which is the constant amount, will go to X. So this is the constant amount. And the I is the interest rate, whereas the N is different from the ones of payments. In this one, the N is the number of payments. Number of payments rather than the number of years. And the P is the present value, or the present annuity is the bigger value that you get presently, whereas the future annuity is the larger value that you get in the future. So how are these two different? When you are dealing with the future annuity, you will notice that the question, a person is paying smaller amounts that are equal each and every term. It can be monthly, 3 months, or a yearly or semi-annually, but is waiting to get a larger amount at the end. So this larger amount is our F because it's in the future. And if a person gets a large amount of money now, perhaps purchasing a car or a house, and is repaying the amount in smaller amounts, the bigger value was at the beginning, and that's the present annuity. So you look at where is the bigger value. I am having small amounts and a bigger amount. Which one is actually bigger? The bigger one is the one that you use to identify the present or the future. So the present is also known as the loan, because if the bank gives you a loan, you get the larger amount now and you will repay it back. So with these ones of annuities, you can give it to the bank and the bank can give it to you. For example, when it comes to the loan, you can win the lottery and give some money to the bank, and the bank will be repaying you back in smaller amounts. So that is the loan. So the bigger amount happened presently. Now let's go and look at the compoundings. With the compoundings, we have to remember something, that when they say it is compounded monthly, then you are dealing with 12. When they say it is compounded annually, you are dealing with 1. Why? The compounding is telling you how many times it actually compound in a year. So if it is monthly, there are 12 months in a year. If it is quarterly, there are 3 months in a year, but you are going to do it 4 times. And if it is semi-annually, it is every 6 months, you do it every time. So how does this compounding work? It works only for the compound interest, and also for the annuities, for the future and the present annuity. For simple interest and for the depreciations, these compoundings do not work. So when you use them, you will, if they say annually, for example, you're going to take n multiplied by 1, and I, wherever you see it, you divide by 1. If they say semi-annually, wherever you see n, you multiply by 2, wherever you see I, you divide it by 2. Divided by 2. So when they deal with quarterly, wherever you see n, you multiply by 4, wherever you see I, you divide it by 4. So these are the compoundings. And then going forward to just read a question where we will be able to understand how to pick an equation. Let's read this question. The question says, John is planning to purchase a house in 10 years. So now we underline the important data. In 10 years time, he deposits 500 every month. Now we are having two categories. We are having two categories of equations. The first category is once off, the second category is continual payment. So now they've just mentioned that he is paying every month. That means this is a continual payment category. And we have only two formulas in the continual payment category, or the annuity. We have the one with the P and the one with F, which is the present annuity and the future annuity. Now we need to understand, where is the larger amount being paid out here? Is it now or is it in the future? So if John is paying, if John is paying, so if this John is actually paying each and every month, we are regarding it as a continual payment. If he paid only once, it was going to be a once-off payment. So the fact that we are having the present amount and the future amount, and looking at what John is going to expect, he is expecting the amount in the future. He's expecting the amount in the future. So our equation is going to be F equals to x into n 1 plus I to the power of n minus 1. So this is the future annuity equation. That is what we are expecting from him. How so? Because he is paying 500 every month and he's expecting the amount after 10 years. Before 10 years, there is no amount. Therefore, the bigger amount is in the future. Let's look at question number 2. for us to understand how to utilize the equations and choose them correctly. It says Buddha is a mechanic at XYZ. He wishes to open his own company. Thus, after winning the lottery, he deposits 500,000. Here's the important information. He deposits 500,000 into an investment account that offers him this much per annum. How much should he expect in 5 years? So first we check, is this a continuing payment or a once-off payment? So it becomes once-off. Reason being, he paid 500,000 and he did not receive anything before 5 years, and he did not pay anything else before the 5 years ended. So he paid only once. That means we are going to use the once-off equations. And this is interest because there is no depreciation here. So is it compound or is it simple? We go and check after the percentage. Did they say compounded? Nope. Therefore, it is a simple interest. So our equation for this one will be A equals to P into 1 minus IN. So this is the simple depreciation formula. Let's look at the last question. While reading it, says the value of bread now in 2023 is this much. By just seeing the inflation rate, I know that the equation is the compound interest equation, which is A equals to